Hello there, AV here! Welcome to the open air test bench contender for this channel, the Thermaltake Core P3. Since there are so many different configurations this case can be built in, you'll be seeing what is built as stands of this second. Stick around to the end for some thermal testing results and a little bit of B-roll, and if you have any thoughts or suggestions for this channel or for this video in particular, let me know in the comments below. Thanks for checking out the video, and I'll catch you in a second for commentary at the end for a wrap-up. The Thermaltake Core P3, contender for the open air test bench for this channel, is a hefty piece of equipment, with a net weight of 12.1 kilos in the packaging. For reference, the last build in the Fractal Design Node 804 weighed in at 15 kilos, with a CPU and GPU custom water cooling loop, including two 240mm radiators. So with that little stat out of the way, opening up the packaging starts off with the usual cutting of the tape, and sliding whatever is inside out of the packaging. But this is where it gets a little more interesting than the usual unboxing. The entire contents of the case and all its accessories are contained inside this polystyrene clamshell packaging. Cutting the tape on this and opening it up reveals the transparent window, which is still covered in its protective film prior to what looks like a laser cutting manufacturing process. It's probably a good time to mention now that you can purchase an additional tempered glass side panel window for this case if that's what you're into. Removing the window reveals the main chassis, which of course houses the majority of the weight, but before we take an in-depth look at the chassis, we'll take a quick look at the rest of the box. First off, we have the user manual, which after building this case holds some information but has no clear-cut guide for any construction order. Next is the single PCI Express riser extender, which will assist with the vertical mounting GPU installation. Notice the black PCBs, which is a nice touch, and anything less would have been slightly off-putting. Moving on is the GPU support bracket, which when coupled with the PCI Express slot cover panel in a vertical mounting position can theoretically support up to 6 single slot cards or 3 double slot cards. But that is limited to 4 and 2 respectively, since there are only 2 riser support brackets included, and they don't appear to sell extras. They do sell extra riser extenders if you want more than 1 vertical card though. However, you can install the PCI Express slot cover panel by itself for the full horizontal 8 single card build. And you can use this 2-slot PCI Express bracket for horizontal installation with any motherboard type, or a vertical installation with mini ITX motherboards only. Then we have the 4 side window support posts, which, thanks to their solid steel construction, have a fair weight to them. Following those, we have the feet of the case, if you choose to have this chassis mounted vertically. I was curious about the construction, so I opened one up. You can see that there is a thick steel base with a plastic cover. Mounted inside the plastic cover are some steel panels, so it's not a fully steel structure, but it's very strong and sturdy in practice, so I've got no complaints here. And rounding off the feet are some large rubber pads at each end. Following the feet is a pump mount panel, which as far as I can tell is completely incompatible with EK mounting mechanisms. The slots are 76mm apart though, so that may help you find something compatible. And then we have the accessories bag, which contains all the screws for the build as well as the mounting feet for a horizontal chassis setup. And finally, the vertical mounting brackets for the power supply unit with micro ATX and ITX motherboards. You may have seen the other bracket earlier, which can mount the power supply units horizontally, which is the only option for ATX motherboards. With all of that out of the way, you'll notice the serious amount of options available here, so let's get the feet on and we can take a closer look at the chassis. The installation of the feet was a little awkward. I found positioning the bolts into the feet first was the best way, but make sure you have a fairly slim screwdriver to fit in between the slots to screw them in. Once the feet are in place, they feel very solid. The threads are nice and strong so you can apply a good amount of force, so we're off to a good start. Now with the chassis standing on its own 2 feet, let's take a good look at it. We'll go over the various holes when we get to them later, but they all have uses and allow for great customizability. The front of the chassis houses the reset switch, microphone and headphone jacks, 2 USB 2.0 ports and 2 USB 3.0 ports, and finally the power button with power LED and drive activity LED just above. The offside panel is purely industrial in design, being a simple large and flat sheet of steel with a large ventilation cutout section, and to the right you can see VESA 75x75, 100x100 and 200x100 for all your wall mounting needs. And the rear of the chassis is again very bare and simple, with only a few bolts and screws here and there. So what's inside the case, or what I prefer to call a chassis? Well, first you're going to need to get the offside panel well off. First 6 thumb screws need to be removed, which is generally quicker to remove with a screwdriver. And then I wasn't quite sure how it was going to come off. It looked obvious that it had to slide off somehow. That somehow turned out to be towards the rear, and the hooks being so prominent with the internal shelves being so large that it removes the chance of it slipping off by accident. It's really very well done. And on the inside you can see a removable magnetic filter, a nice impressive start. To the front of the inside you can see that the feet are screwed into a very thick steel angle, and further up is the rear of the front I/O, which you may notice has a black PCB again. They could have cut the corner and cost slightly with a standard green PCB, but they didn't, and that's a nice attention to detail. And of course, the top includes another one of those heavy duty brackets. Just to the right are 3 slots for 2.5-inch drives that sit behind the area for the radiator mounting position, which can fit up to a 360 or 420mm radiator. And the rest of the case has 2 lower cable management holes, a huge bracket to support wall mounting which also has cable management holes behind it and above it, and 2 3.5-inch drive brackets which can take 2.5-inch drives too. So we're 6 minutes in and we're yet to actually build a system. Let's deal with that problem. Normally I would grab the MSI Z170M Mortar Micro ATX motherboard off the shelf, but since this is set to be a more permanent open air test bench, I'm gonna need something I don't need for all the Micro ATX cases I look at. So we're going to be using the Asus Z170 Pro Gaming ATX motherboard, which should mean system swaps for upcoming CPU cooler reviews will be that extra bit more time efficient. It would also help if I had an extra 6700K lying around, but we can't have it all. Since the water cooling parts were very recently in use, this build is going to be water cooled, which means we're going to need to transition the RAM, the CPU and the CPU water block over to this new to the channel but admittedly old motherboard. If you're transferring a CPU from one motherboard to another, it's worth giving the CPU a good clean to make sure there isn't any thermal paste getting transferred and introduced into the other socket. The socket cover is something I find gets a little awkward to work with after the first installation, so I tend to get rid of it before future installations, and then it's a simple case of lowering the CPU into the socket. Just make sure you place a compatible socket cover onto the motherboard now not in use, then the rest of the CPU water block can be quickly removed and installed onto the new motherboard. A super quick installation of the CPU water block starts with the backplate and hold down posts. Then a small application of thermal paste can be applied and the CPU water block can be lowered into position. With the block in place, the pressure balancing springs can be dropped over the posts and the thumb screws can be screwed down into the posts, which closes the CPU water block installation. Now what's left to do is to throw the RAM into their slots and we can move on to actually installing the motherboard into the chassis. First things first, the motherboard standoffs need installing. The ATX layout for this motherboard requires essentially 3 rows of 3 standoffs. I can 100% say this is the easiest standoff installation I've ever been able to do. Following that note, this is definitely the easiest motherboard installation I've ever been able to do. This isn't exactly a surprise from what is essentially just a chassis, but it's still a really nice experience, and if you wanted an open test bench, you could use the included feet to allow the chassis to sit in this position permanently for very quick component changes. With the motherboard in position, with the CPU and RAM installed, I decided I wanted to install the power supply unit, more on that in a second. There are several markers on the chassis that correspond to the sets of holes. I'm using the second set from the left, suitable for 180mm power supply units. The other set suits 200, 160 and 140mm power supply units. To support the rear of the power supply unit, this bracket needs to be installed. Note that with the other included bracket, you can install the power supply unit vertically when using Micro ATX and Mini ITX motherboards, but there is only horizontal support when using ATX motherboards. Unfortunately, the chassis has to be tipped over to secure the bracket to the underside of the chassis, but I think it doesn't look too bad and it creates a strong support for the back end of the power supply unit. So far, so good. Also note this bracket has a few installation positions as well, which means you can choose where your power supply unit is supported. I think having the rear of the power supply unit nice and close to the grommet is better, since it reduces the amount of cable on show, and since they aren't really nice custom cables, which I can imagine a lot of you either have or are going to have, it's best to keep them out of sight. Now for the storage of this system. Long-term viewers may be interested here since I'm making a minor upgrade. The usual system will now be having 2 SSDs. The extra SSD has come from my laptop to work as an editing storage device, so I won't be editing from a hard disk drive. It actually hasn't made the major difference I thought it would make, but we'll see if this improves. The positions do seem really unusual. I was very skeptical since they will be right behind the radiator and may interfere with airflow. For those as skeptical as I am, make sure you catch the thermal testing results at the end to find out how it performs in this configuration. The 3.5-inch hard disk drive bays are pretty smart in my opinion, however they could be very slightly improved. They come away from the case very simply with the removal of one screw, but since I use 2.5-inch hard disk drives, one of the 3.5-inch drive clips needs removing, which is a little annoying since I need to put that random clip somewhere. But then again, since there is a fair amount of spare hardware from the case anyway, it can be stored away with those, so all round not too bad. Now for the installation of the GPU support bracket, but let's pause things here and take a step back. I know what's coming and it's not pretty. My build order for this chassis is all wrong and you'll see some of the results of that in a bit. So, here's how I'd install it all knowing what I know now. First, the PCI Express slot cover panel should be installed. Then the PCI Express riser extension support bracket with the PCI Express riser attached should be installed onto this GPU support bracket. Then the GPU support bracket should be installed with all the previous installed on it, and then the power supply unit support brackets should be installed with the power supply unit. If you're getting this case, please take that advice with you if you don't take anything else away from this video. So, installing the GPU support bracket requires 4 screws to be installed, one for the top for what I presume are support strength reasons, and 3 below, which by itself is not an incredibly strong connection, but not too bad. But of course there isn't a valid reason why you would have just that bracket by itself. It works and is designed to work with the PCI Express slot cover panel. The PCI Express slot cover panel fixes to both the GPU support bracket below and the chassis, which creates an incredibly solid build, easily capable of supporting 3 dual slot GPUs, if you can somehow get your hands on another PCI Express riser support bracket, which we'll see soon. Also, keep in mind this PCI Express slot cover panel can be mounted horizontally for a more standard GPU mounting directly to the motherboard. Now, this is where my build order gets a little strange or inefficient. The furthest supported point of the GPU support panel needs some support. This comes in the form of what I'm calling a support rod. This support rod needs to be fixed to the power supply unit bracket from the underside with a screw, which would have been simpler if I'd done this in the order I mentioned earlier. For your information, the manual for this case doesn't explain a certain build order. To be fair, it's very hard to explain the best way to build a case when there are so many options, which will hopefully make this video somewhat useful for at least this setup. The support rod of course needs a screw to fix it to the GPU support bracket. It's here I feel it would have been nice to have a few select white screws available, but that's just an opinion and obviously nothing to do with how the case performs. Again, here is where I stress that build order is crucially important for an efficient build time. I had to retroactively remove the GPU support panel to fit one of the 2 included PCI Express riser support brackets. They take 2 screws, one each side, and can be placed in 3 different positions. In each position, the bracket can support a PCI Express riser extender on each side. Hence, if you had 3 instead of 2 provided, you could install 6 single slot cards or 3 double slot cards. If I had any brain power left at the time of this build, I would have attached the PCI Express riser extension cable as well at this point. But I was a bit shot, so after reinstalling the GPU support bracket, I did what I felt was the quickest and most creative way of securing the screws into the standoff. Needless to say, I was pretty pleased with myself. Anyway, once the riser extender is in place, the GPU, which in this case is the EVGA GTX 1070 for the Win Edition, can be pushed down into the PCI Express riser, and can be secured to the PCI Express slot cover panel by replacing the 2 screws of the covers removed earlier. Another do as I say not as I do moment is to install the front I/O connectors before installing the GPU. All the storage drive SATA cables can now be connected to the motherboard. At the moment we have a total of 4. I tried my best to keep them all the same colour, and I rearranged these later to make a more symmetrical cluster, which you may see a little later in the B-roll. To get the full picture of the system before putting the rest of the water cooling loop in, the GPU power will be connected. The eagle-eyed among you will notice there is a missing screw from the GPU. Reckless I know, but there we go. Moving on. We're going to be running both the CPU and GPU on this rather meager single 240 by 39mm radiator. Check out the thermal testing results at the end to find out how it compared to the rest of the cases tested so far. The installation, as expected, was extremely easy, apart from the odd cable being slightly in the way, but I think we can all safely say we've dealt with worse. Of course, the EK Varda F4 120ERs, which spin up to a respectable 2200 RPM, are being used for this system, which will be running at their maximum speed for thermal testing later. For the pump res combo unit, I needed a little extra bit of a mount to offset the reservoir from the RAM, so I used one of the 120mm fans with a bracket. I know this is a really weird configuration, but I wanted to keep everything within the profile of the chassis, and neither of the two EK 120mm pump mounts are compatible with the Thermaltake pump support bracket. Connecting the radiator to the pump was a fitting intensive task. Unfortunately, I don't have any specialist fitting to make more use of tubing. However, there was a small, barely noticeable section of tubing used in the middle. We'll take more of a look at the connection between the CPU water block and the GPU in a second, but a healthy amount of tubing was used to connect the radiator to the GPU water block, as well as a couple of angle adapter fittings. So before we go into the filling, I want to go over a few things. Things I probably wouldn't recommend with this build, and reasons why it is why it is. We'll go over that first actually. The reason it is what it is because I want to get a very quick build done in here, just to see what the case is like, to see what the chassis is like, to give you a review as quick as possible. I don't need to do any more than this to tell you what this case is like to build in, which we'll cover a little bit more at the end. But yeah, so going over why it is what it is. The amount of fittings used in this chassis, in this build, is ridiculous. Connection between here and here, although it's a small distance, there's a very slight change in elevation and direction. It's coming out slightly and it's raising slightly, so that really does encourage use of fittings. So where you think, if you're a first time builder, you could go from here to here with a fitting and a bit of tubing and another fitting, that sort of thing doesn't really work out in reality. I could potentially change things around to make it work a little better, but actually looking at it, unlikely. If I maybe put the fans and the radiator in a different configuration, that might work, but it's a little difficult. So a lot of fittings around this area too, huge amount of them. Really would like to cut that down. I did my best. I think I spent about an hour and a half trying to work out the most efficient way that would actually work. There's only, I think, 2 different ways that would work that I found, and this one was the best one, would you believe it? I've changed the position of the fill drain port to go around to the other side. You might have seen it on the other side in the previous bit of the video. I haven't edited it together yet, so we'll see. But it's on that side now for convenience sake. I've actually got to tilt this case over by 90 degrees. I say case, it's more of a chassis. Tilt the chassis over by 45 degrees so gravity can do most of the work with filling, and it means that I should have a better grasp of when the system's completely full at the end. You might get a better idea of that when we go and I've done the filling and that sort of thing. So yeah, we'll fill it up. We'll see what it all looks like. So like I say, very quick build, so I can get into doing things like CPU cooler reviews and more case reviews as fast as possible. If I spent more time trying to make this really pretty, then that really affects the time that the video would come out, and I put that in a higher regard to the way that the actual build looks, in my opinion. I don't know if your opinion is different. Let me know in the comments if it is. So yeah, I'll crack on with the filling. I hope you enjoyed the video so far. I hope you enjoy the filling. Hope you enjoy what it looks like at the end, and I hope you enjoy the thermal results, which we'll check out in a bit. As for the filling, I made the mistake of lifting the system and rotating it rather than rolling it. It's likely over 20 kilos and it could slip pretty easily, resulting in some serious damage, so I don't recommend it. And although leaning the system on a few boxes supported by the radiator and fans connected to the system worked, I really wouldn't recommend that either. The only reason I haven't added a simpler filling system is because I really don't like the look of an afterthought random drain port sticking out from an easy to see part in the system. With the system on its side and ready for filling, the filling and draining tube can be connected to the fill and drain port. I found using the PCI Express slots to assist holding up the tubing helped a little and allowed me to get some better angles on the action. And just to make sure I had as much liquid in the system as possible, the chassis was laid down flat to top it up. Getting a final glimpse of the cable management, it's not as clean as it could be, but that's the beauty of having a solid side panel. It's worth mentioning that you can remove the large wall mounting bracket in the center of the case, but I found it was useful to wrap excess cables around the sides, since there aren't any cable management loops. And replacing the side panel was just as easy as it was to take off. If you're the type of person to be in and out of your system constantly, you could only replace a couple of screws and you'd be fine. You could even leave the screws out. There isn't an issue of the panel rattling around since it's a tight enough fit. Unfortunately, when I went to turn the system on for the first time, there was no post, and the VGA LED was lit. So I tried several things, including running without the GPU and removing 3 sticks of RAM, which fortunately there was just enough room to do. So the issue was not the RAM, the issue was nothing to do with the post lights, the issue was nothing to do with the graphics card, although the graphics card isn't actually plugged in as of yet, so who knows if that'll kill it again. But to actually get it to post was a case of nothing. It was actually posting, it was the monitor that was not plugged in quite right. The cable was in, it was just not in enough. It was actually working before, I hadn't touched the cable, so yeah, dodgy monitors. So that's all up and running. Glad that's working. So if you want to check out some thermal results, then wait for 1 second. So with the system up and running, I was absolutely astonished by the thermal performance. With just one 240mm long and 39mm thick radiator, this system has the CPU averaging at 56 degrees and the GPU ending its parallel 10-minute test at 36 degrees. Compare those results to the rest of the cases tested so far and you can gain an appreciation for how layers of filters and ventilation restricting panels of most closed construction cases can reduce laminar low resistance airflow. If you look to the left of this graph, I've displayed the radiators used for each of these cases. And yes, we're looking at an open test bench with a single 240 long and 39mm thick radiator, outperforming two 240mm long and 26mm thick radiators in these closed style cases. At least for me, that answers the question of, does ventilation design really make a difference? Finally, please enjoy the B-roll and I'll catch you at the end for a wrap up. And don't think I forgot about that side panel window. So a very interesting build of a high-performing water cooling loop in the most robust case I've had my hands on. Truly, this thing is built like a tank, and I would thoroughly recommend it to anyone looking into this sort of thing to strongly consider the P3. If this one isn't big enough for you, there is the huge Core P5 and the even bigger P7, and the price tag is not far behind them. I'd also recommend checking out the Core P1, which is a purely mini ITX version of this case that looks absolutely fantastic. And to end the video, a huge thank you to all of you watching. Like I mentioned in the update video last week, this case was part funded by all of you watching the ads in these videos. Let this open test bench represent the 500 subscriber milestone we smashed last week. If you haven't already, make sure to subscribe to AV Techy if you want to check out more future videos like this one and all the testing I'll be doing with this test bench. Finally, thanks for checking out the video and thanks again for the support. I'll hopefully catch you in the next one.